In this video, we are going to have a look at the topic of related rates, which is part of the IB Maths, the Applications and Interpretation, so the AI course, but for HL students. Now, related rates is part of topic 5, calculus, and it's in the differential calculus subtopic. Okay, so related rates questions are these calculus-based questions where we need to find rates of change, and we need to try and find two of them and how we can relate them. And I'm really trying to use the keywords here. Can we relate some rates to help us try and solve some types of problems? Now, in this video, I'm going to give you an example. I'm going to show you the steps to solve this example, but these are the steps here, the 5 steps that can help you solve any related rates problem. Okay, so let's have a look at our solution here. Let's have a look at our example here and find our solution. We have a 5-meter ladder that rests against a vertical wall with its feet on horizontal ground. The feet on the ground slip, and at the instant when they are 4 meters from the wall, they are moving at 5 meters per second. And we want to find the speed the top of the ladder is moving down the wall at this instant. Okay, this is our related rates problem. Let's have a look at our related rates steps. Step 1, let's draw a diagram. Okay, so I'm going to draw a diagram of a wall. Let me draw a wall here. We have our wall. I know we have the horizontal ground, and I know we have our ladder. So let me draw our ladder, and this will be our blue ladder here. Okay, now once we have drawn our diagram, what we want to do is we want to write down all of the given information. So let's substitute in all of our information here. We know that our ladder is 5 meters long, so I'm going to write down 5 meters. And what we do know is at the instant when the feet are 4 meters from the wall. Now I'm going to define this distance here, the distance that the feet are from the wall, x. So let me just draw here. I'm going to define this distance as x. I'm going to define the vertical as y. What I know is that when x equals 4 at this instant, the feet are moving at a speed of 5 meters per second. And the key here is to understand that if x is the horizontal distance, the rate that x is changing is the speed. And therefore that will be dx dt. So this will be 5 meters per second, and that's when x is 4 meters. Okay, that's very important here. At the instant where x is 4, the speed that x is changing will be 5 meters per second. Okay, now what do we want to find? We want to find the speed the top of the ladder is moving down the wall. So we want to find dy dt. dy dt equals question mark. That's what we want to find. Okay, step 2, completed. Let me tick these off as we go. We have drawn a diagram and we've written down all of the given information. Step 3, we want to write an equation connecting the variables, and the variables here are x and y. How do we write an equation that connects these? This is where you might need to use Pythagoras' theorem or similar triangles, or maybe the sine and cosine rule, one of our geometry formulas here to try and connect these two variables. And in this example, it's pretty easy because we have a right-angled triangle, so we can use Pythagoras' theorem. So if I want to write down an equation that connects x and y, let's do that over here. What I can say is, well, I know that x squared plus y squared will always equal 5 squared in my example here. It doesn't matter if the ladder is leaning, is very close to the wall, or if it's quite a long way away from the wall. Because we always have a right angle triangle here, we know that the x distance squared plus the y distance squared will equal 5 squared. So what I can do from there is I'm going to try and rearrange this to try and get something to be the subject. And what I like to do is look down at what I want to find, dy dt, this y here, I want y to be the subject. This is going to help us when we try and do step 4. So because we want to find dy dt, I'm going to make y the subject here. So let's make this y squared will equal 5 squared, which is 25, minus x squared. And then I'm going to say, well, y is equal to the square root of the right-hand side, but I'm going to write that as 25 minus x squared, all to the power of a half, instead of writing the square root. Okay, so this is step 3 completed. I have written an equation connecting the variables, and it's this here. Okay, let me tick off step 3. Step 4, use the chain rule to differentiate the equation with respect to t. So what we want to find is the derivative of y with respect to t. This is where we need to use the chain rule. The chain rule, let me write the chain rule. This tells us that if we want to find dy dt, what we can do is we can find dy dx and multiply that by dx dt. Now, some students find this a little bit difficult to really grasp, but the chain rule tells us that if we have y as a function of x and we want to find dy dt, we can take the derivative of y with respect to x and then multiply it by the derivative of x with respect to t. Now, if you don't like that, if you're really scared of the chain rule, I like to often say to students, well, at this step here, step 4, if you don't like the chain rule, I'm just going to use green here as my thoughts for students. What do we want to find? We want to find dy dt. That was the question that was asked to us. So I'm going to make this equal to something multiplied by, and what were we given? We were given dx dt. We were given dx dt. So if we want to find this, and we were given this, well, what would we need to multiply this by to get this? And you might be able to just actually work it out. Well, if I have a dx on the denominator and I have a dy on the numerator, notice that the dx would cancel out and dy dt is in fact equal to dy dt. So that's an equation which has satisfied all of our rules. So if we can just find dy dx and multiply it by the given dx dt, we will find dy dt. So this is for students who like to really visualize the rates that we need to find, but if you are strong with your chain rule, we know we can find this here. Okay, so let's go back to what we had for our working. I'm going to rub this out. So dy dt, which is what we want to find, this will be equal to dy dx, which we can find by simply taking the derivative of y here with respect to x, and then multiplying it by dx dt, which was given in the question to be 5 at this instant. So let's find dy dx. So I'm going to find dy dx using the chain rule. So the 1/2 will come out the front. It'll be 1 over 2. We have 25 minus x squared, all to the power of negative 1/2. And then we need to multiply this by negative 2x. Hopefully you have seen the chain rule before. The 1/2 comes out the front. We rewrite our bracket. We reduce the power by 1. And then we multiply on our numerator by the derivative of what's inside of our bracket, which will be negative 2x. And we can simplify this. We will get the 2 cancelling out with a 2. We have negative x left over on our numerator. So negative x. And on our denominator, we will have the square root of 25 minus x squared. And hopefully I didn't lose anyone there. The negative x stays on the numerator. This here is to the power of negative 1/2. So I've brought it down to the bottom, which would be to the power of positive 1/2. And then I replaced it with the square root sign. Okay, so back up to our solution. We have dy dt. This is equal to dy dx, which we now know is negative x over the square root of 25 minus x squared, and we're going to multiply this by dx dt. Now, it's at this step here that we can go to step 5. We can substitute in, I'm going to tick step 4, substitute in all of our given values, because we wanted to find dy dt, the speed, at this instant, and at this instant, x was 4. Let me put here, x is 4, and dx dt is 5. So let's substitute that in. We're going to have dy dt. This will equal negative, and I'll put in the x in red here just to make sure we can visualize what we've subbed in. We have the square root of 25 minus, I have my x, which is 4 squared, and I'm going to multiply this by dx dt, which I know is 5. So I've really substituted in all of our given values at the instant. Okay, let's calculate this now. We have dy dt equaling negative 4 over, and the square root of 25 minus 16 is the square root of 9, which is just going to be 3. Let's times this by 5, and what we will get here is negative 20 over 3. Negative 20 over 3, which as a decimal is negative 6.66 recurring. So I'm going to go negative 6.667. Okay, now this makes sense why the answer is negative, because the ladder will be going down the wall. And if y is considered positive going up, well, the ladder is clearly going to be going down. So what this answer is here is we can say the ladder is moving down the wall. The ladder is moving down the wall at a speed, which is our dy dt. If this is negative 6.67 to 3 significant figures, the ladder is moving down the wall at a speed, and we don't need to have a negative sign for speed. Speed is positive, so a speed of 6.67 meters per second. And we don't need to put the negative sign because we did say it's going down the wall. Okay, so this is our answer to our related rates problem. Hopefully what you can do is take away here our steps, the related rates steps, and if you apply these 5 steps to all of our related rates problems, you should be able to solve what the question is asking for. Okay, good luck.